The Great Moons of Jupiter. Discovered 400 years ago by the astronomer Galileo, the 4 largest moons are so big they were discernible through his primitive telescope. Jupiter has at least 60 moons, many mere chunks of rock. With 3 rings of dust as tenuous as gossamer, Jupiter is more than 5 times farther from the Sun than is Earth. Out here, it takes nearly 12 years for a solar orbit. Jupiter is the biggest planet. Earth would fit 12 times across a diameter of almost 143,000 kilometers, and Jupiter could swallow Earth 1,323 times. Another vital statistic: while Earth, not to scale here, has a tilt of 23.4 degrees, Jupiter leans at just 3 degrees. In mythology, Jupiter rules heaven and earth, but compared to the Sun, Jupiter is a lowly lord, too puny to qualify even as a failed star. Yet Jupiter is bigger than all the other planets combined, a ball of gas, 90% hydrogen, the rest mainly helium, spinning on its axis in less than 10 hours. En route for Saturn in the year 2000, the Cassini spacecraft imaged the vast weather bands of Jupiter. The white and yellow zones are high cloud, the red and brown belts low cloud. The bands blow in opposite directions. Time-lapse shows eddies and storms racing round the planet. The bands are all we see of this world without a solid surface. Lower left is the Great Red Spot, a tempest that's raged for centuries. It's an anticyclone, 3 times the size of Earth. Cassini showed the polar regions. With less banding, the weather is quieter. (1989), and Space Shuttle carries aloft Galileo. 6 years later, Galileo drops a probe into Jupiter, a colossus whose average density is like potato soup. First encounter, the stratosphere, thin and bitterly cold. Beneath are ice clouds, as pressure approaches that on Earth. Lower, through stinking gas, pressure and temperature build. Then, surviving winds and lightning, the craft is lost in an atmosphere 18 times denser than Earth's. In 1 hour, the probe had penetrated only the atmospheric skin. Jupiter has 5 cloud layers. Topmost, the wispy stratosphere. Beneath, ammonia ice crystals. In the middle, smelly ammonium hydrosulfide. Then water ice crystals, and below water like a deep warm ocean on Earth. The atmosphere disappears in the layer beneath. At 2,000 degrees and 1,000 kilometers deep, hydrogen turns liquid. Deeper still, hydrogen becomes a metallic liquid. At the rocky core, it's 20,000 degrees. Jupiter's vast magnetic field springs probably from the internal layer of metallic hydrogen, which conducts electricity. At the poles, the result is aurorae. Charged particles drawn from space interact with the upper atmosphere. Jupiter's magnetic field is the biggest in the solar system. If we could see them from Earth, the force lines would appear as big as the Moon. Like a donut in the magnetic field, a ring of electrically charged particles, the Io torus. It carries 2 trillion watts of power. The cause is the moon Io, which orbits in the Io torus. Having dropped its probe into Jupiter, Galileo flew by Io in a series of loops around the planet. Io is the closest major moon. Larger than our moon, but unlike the moon, Io has no craters. The reason is volcanic activity. Constant eruptions, here in blue, renew the surface, and they feed charged particles into the Io torus. Io's surface is a sizzling pizza, the most volcanically active in the solar system. The cause is probably gravitational flexing, the pull of both Jupiter and the moon Europa. This moon is Jupiter's biggest, Ganymede, with a diameter of more than 5,200 kilometers. Set against the planet Mercury, Ganymede is bigger. Its largest feature is Galileo Regio, the dark disk. Rich in impact craters and grooves, the ridges are a kilometer high. Galileo detected a weak magnetic field and clues to Ganymede's interior. Beneath the crust are possibly a slushy sea, a layer of rock, and a metallic core. Another Galileo encounter, Callisto. Outermost of the big four, Callisto is heavily cratered. This, the Valhalla Basin, 3,000 kilometers wide. Another impact site, the Asgard Basin. Callisto is thought to have a crust of ice and rock overlaying, some believe, a salty sea. Jupiter's fourth great moon is Europa. Europa is an extraordinary world, crisscrossed with icy ridges and glacial ravines. They're caused as icy plates break up and shift. White material is water ice, red is dirty ice containing salts or silicates. These freckles suggest warmer ice is churning from below, while colder ice is sinking. Like this sea ice on Earth, Europa's shell may well conceal an ocean. And what an ocean! Bottled up below an ice crust that may range in thickness from a few meters to several kilometers. A deep ocean, salty and warm, heated by tidal stresses from Ganymede and Io. As in earthly oceans, hydrothermal vents may spew volcanic gases. Best evidence for the ocean came when Galileo detected electrical currents beneath the surface. That inspired several ideas. This one, still in development, is a mission to Europa along with Callisto and Ganymede, which may also have oceans. It's called the Jupiter Icy Moons Orbiter. First, scanning Callisto, data will provide comparisons with Ganymede, the second target. How did they evolve? Can oceans be proved? Could they sustain life? At Europa, the same questions, plus, where's the thinnest ice? Later, another craft will be dispatched to Europa, this time with a lander. Armed with information from the recce, touchdown will be where the crust is thin enough to bore into the ocean. Deploying a robot submarine, a hydrobot, there'll be a search for life. If simple organisms are found, they could have evolved, as in our oceans, around hydrothermal vents. From the tiny craggy moon Amalthea to giants like Io, Jupiter rules a mini solar system. Europa, like Earth, may have oceans and life. Ganymede, like Jupiter, is the biggest in its system. Callisto, like Mars, is outermost of its class. Farther out, a swarm of little moons, altogether 70 and rising.